Welcome back, everybody. This is going to be part 2 of 2 on my lecture series on linear functions. In this video, we're going to talk about parallel and perpendicular lines. Let's get started. We call two lines parallel if they have the same slope. And we have this little symbol, two vertical bars pushed up next to each other, to represent or write quickly that one line is parallel to another. So, how do we find the equation of a line that runs parallel to y equals 3x minus 5, but passes through 2, 2? Then, once we find it, let's sketch the graph of each of them. So, remember, I always only need 2 pieces of information to write down the equation of a line. I need a point on the line, check, and I need the slope. Also check. Remember, 2 lines are parallel if they have the same slope. So, since it's parallel, I know my slope is going to match this one. And this is written conveniently in slope-intercept form for me. So I know the slope is 3. Oops. My slope is 3, and my point is 2, 2. So I can use the point slope formula to write y minus y coordinate equals m times x minus x coordinate. It's typically easier, though, to write this in slope-intercept form for the purposes of sketching the graph. So, solving for y, I get y minus 2 equals 3x minus 6. Adding the 2 over, I get y equals 3x minus 4. I'm going to give myself a little bit more room here so we can sketch the graph. And here, I'm going to count by 2's. So, for my first function, that's y equals 3x minus 5. Its y-intercept is at -5, and its slope is 3. So I use my rise over run. I'm going to rise 3 units and run 1. Rise 3, run 1, and so on. There is 3x minus 5. This point, or this line, is 3x minus 4. So I go down to, and I actually need to fix that a little bit here. There we go. My y-intercept is at -4. Slope is the same. Rise 3, run 1. Rise 3, run 1, and so on. And these lines are a little bit close to each other there, but notice that they never intersect each other. That's a really cool property of parallel lines. A perpendicular line, or 2 lines are perpendicular if their slopes are opposite and reciprocal. And we write this kind of upside down capital T to denote perpendicular. So in this example, I'm asking you to find the equation of the line that falls perpendicular to y plus 2 equals -1/2 x, and that runs through the origin. And again, sketch the graph of each. Well, first of all, it'll be helpful to write this in slope-intercept form. So y plus 2 equals -1/2 x is almost in slope-intercept form. I just need to move the 2 over. Y equals -1/2 x minus 2. Now I know this guy's slope is -1/2. So my opposite reciprocal or perpendicular slope is going to be opposite of that, positive, reciprocal of that, 2. I flip it over and change the sign. Similarly, I need to know the y-intercept. But I know it runs through the origin. That is where x equals 0. So the y-intercept is 0. Now I can write down the equation of the line in slope-intercept form. And it's going to be y equals mx plus b, 0. Let me give myself a little bit more room here to sketch the graph. My original line has y-intercept -2, slope -1/2. So I'm going to rise down 1, run 2, down 1, run 2, and so on. There we go. That's my original line, y equals -1/2 x minus 2. I know for my other line, its y-intercept is 0, and its slope is 2. So I rise 2, run 1, rise 2, run 1. And you'll notice here that these two lines intersect at a right angle, and that is a fun property of perpendicular lines. In this video, we looked at parallel and perpendicular lines and how to use the properties of them to find the equations of related lines. That's going to wrap it up for this lecture series. I'll catch y'all in the next one.